All right, this is the Your Turn problems from section 12.3. Hopefully you've done these on your own. If not, shut this video off and try them on your own before you see me do them. I'm going to do problem number 1 in one video, then problem number 2 in another video, problem number 3 in a third, and problem number 4 in a fourth. So here we go with the first one. We have finding the least common denominator. So least common denominators, we're going to start out by factoring the denominators. So x squared plus 2x plus 1 is a perfect square trinomial. We have two perfect squares and the product of their roots give us the 2 in the middle. Therefore, we know it's a perfect square trinomial, and it factors as the sum of their roots quantity squared. Now this one over here is the difference of two perfect squares, which factors into the sum of their roots and the difference of the roots, the product of conjugates again. And now, once I have that, I can find their least common denominator. So I'm looking at the unique factors of x plus 1 and x plus 2. And then once I have the unique factors, then I find the highest exponents of each of them. The highest exponent of the x plus 1 is squared, and the x minus 1 is just to the first power. Remember, you're not putting in the x squared plus this one over here. It's not a third power. It's the higher, 2 versus 1, which is higher, 2. And that's our least common denominator. Now moving on to our second one here, we have factoring a least common or a denominator down here where we have a leading coefficient. So we can say 4 times 3, which is 12, and then the factors of 12, 1 and 12, and 2 and 6, or 3 and 4, which are going to sum to 13. And so I see that 12 and 1 are the factors that sum to 13. So if I can take the factors of the 4 and the factors of the 3 and make them multiply in ways that I can get a 12 and a 1, then I can get this to happen. So 4's factors, 4 and 1 here, placed with 3's factors here and here to give me an outside product of 12 and an inside product of 1 will sum to 13. And so that's how that one factors. Now coming over here, these are all even. So I'm going to take out a GCF first of 2. So that's a 2x squared, or 2 times x squared plus 6x plus 2 will come out of there 9 times. Now what I see here is a perfect square trinomial. Perfect square, 3 times 1 times 2 is equal to 6, so it's a perfect square trinomial. So this one further simplifies down to 2 times x plus 3 quantity squared. Now once I have that, I can find the least common denominator of these. And the least common denominator, all the unique factors that I see up here. So I have a factor of 2, I have a factor of x plus 3, and I have factors of 4x plus 1. And then I look for the highest exponents on each of these. So the factor of 2, the highest exponent is 1. Factors of x plus 3, 1 here, 2 here, so the highest one is a 2. And then the 1 here for the x plus 4x plus 1. And there's my least common denominator there. All right, come back and join me for the next video, and we'll talk about the examples number 2 in the next problem, where we're going to take these two that we just found the least common denominators for and build the higher terms this time around.